We're now going to talk about some simple rules for graphically depicting groundwater flow if we know some very basic boundary conditions about the system of interest. And we're going to start simple. So let's assume some simplifications first when we're doing this to make our lives easy. Let's assume that we're talking about homogeneous flow or a homogeneous aquifer. It's going to be totally saturated. It's isotropic, and it's a steady state aquifer. Okay, if this is true, then we know some things, and we're going to make some rules here. So we know that if we were to draw lines of constant head in the subsurface, those lines would be called equipotentials. And we know that flow must be everywhere perpendicular to these equipotential lines. And this is the same thing. You know, if you were looking at a topographic map and you were asking which way is overland flow going, it's following the path of steepest descent. It's perpendicular to the elevation contours. Groundwater flow is perpendicular to lines of equal hydraulic head in the subsurface. So that's one of our rules here. And the second rule is that these equipotential lines are themselves perpendicular to no flow boundaries. And I will sketch out what that means. So, in this case here, let's say that I had a no flow boundary. This was just a totally impermeable boundary here, denoted with these dashed lines. The equipotential lines must be perpendicular to it. And therefore, we know that any flow, because it must be perpendicular to the equipotential lines, the flow must be parallel to a no-flow boundary. So this is our flow line. If we have a constant head boundary, for example, a water table, the flow lines must still be perpendicular to the equipotential line. So to summarize that, the flow is perpendicular to an equipotential line that is a constant head boundary. And if you have a no flow boundary, equipotential lines must be perpendicular to it, and therefore the flow, which is perpendicular to the equipotentials, must be parallel to the no flow boundary. These seem like fairly abstract rules. We'll put them into practice with an example that'll make it a lot clearer what we're talking about in the next video.